Okay, let us start our discussion on isolated point. What is the, as the name indicate, isolated means it is a alone point, we can say that. Why it is alone? The question comes. How can we say that it is alone? Suppose they given function y is equal to f of x and they also given point x1 and y1. And how this point is satisfying this equation? Let us we say that they given that x1 is y1 is satisfying the function. Now, how can we say that it is alone? Very simply, there should be no neighborhood points around that which is going to satisfy the equation. How to check it? Very simple. Means alone means there is no neighborhood points, or isolate means isolated points. There are no neighborhoods left side or right side there which should satisfy the equation of the curve. How can we choose? How can we say that? Very simple. Pick a very close point x2 to the close to the x1 and find out by putting x2 is equal to x1 plus delta x1. And if you put the equation of the in the that equation, you can get whatever the y2. It should be equal to the y1 plus delta y1. And delta x1, you can say that. But is it sufficient? No. You have to observe the pattern. What means still if you bring close x3 even closer to the x1, whatever this delta, whatever you can say that, then you can say that x3 is equal to x1 plus delta x2. You are telling whatever you choose. Okay, then that delta x2 should be less than delta x1. Then even if whatever you get y3 should be still closer to the y1 than the y2. Means that as delta x in decreases, delta y also decreases. What it means, the point squeezes. Then we can say that there are surrounding points around that point. Means what I want to say is that whenever if you bring closer point to that one x1 neighborhood points, if you go on approaching x, the x approaches x1 here, okay, x approaching x1, whatever the points y coordinate also should approaches y1. That should happen, then only you can say that. Otherwise we should not happen. What happens if you may ask that if it is not happen, what will happen? Means there is a, I can say that gap will occur. Means there is, you can say that, then it is called, if this observed pattern is observed like this, then whatever the point is not isolated point, keep in mind, because there are surrounding points are there in x1 y like that. But taking the different 2 to 3 points, checking the observation is very difficult. How to find them? Then what happens, what we observed that means that if you check what happens left hand continuity and right continuity, because what happens sometimes we observed as x tends to x1, whatever the f of x, suppose I can say that initially we have x and y point, y is equal to f of x is there. If you x is equal to, if you take x1 minus delta x, means we are going to choose the left point of the x coordinate, then whatever the y coordinate, y is equal to f of x should tends to y1, because we are, means what happens, what I want to say is that if you take for example we have x1 y1 point which is going to satisfy the equation of y is equal to f of x. Okay, I will repeat once again. Suppose y is equal to f of x is there. Suppose there is a point x1 y1 is there which is going to satisfy the equation of the curve. Then I need to check whether the x1 y1 is isolated point or not. What we can say that as x approaching x1 from the left side, means x should be taken is x1 minus delta x1. As delta x tends to 0, what happens, this x approaching x1, if you get f of x is very close, y is equal to f of x, we can say that whatever the point you can get, if it is close to the y1, then we can say that uh, left side, okay, means there is a left side, a closely point exists in the point of the left side of x1 y1. But simply checking the left side is not sufficient, because somewhere the curve is like that curve breaks it left, maybe it may be a continuous set, the left side may not be continuous set the right side, then it is not isolated point, because there are neighborhood points around the point left side. Okay, then we can say that if f of x approaches y1, then there are left point exist, left continuity exist. If it is not exist, okay, there is no left continuity. But if you coming to the right continuity, if you choose the point around the x1 and left side, that is if you take x is equal to x1 plus delta x, what happens, the whatever the f of x is close to the y1, you should get it. Means that as delta x in decreases, as delta x decreases, whatever the f of x should be greater than approaching, it means that the limit of f of x as x tends to x1, as x tends to limit of f of x as x tends to x1 means delta x tends becoming 0, it should be equal to y1. Not only it should both on left side and right side. Why? Because whenever if it is only, I can say that if you let us assume that there is no left continuity, if I say this the point is isolated, you cannot, you need to check right continuity, maybe there may be closely associated point also on the right side, therefore you have to check on the right side also. If the both the limit, I can say that if they both have left continuity, and what we can say where continuity means whatever the function value is tending to f of x1 here, as we see here, whatever the limit of f of x as x tends to x1 means, which is equal to y1 means what this becomes, because y is equal to f of x means f of x1 is y1 here. Try to understand. Therefore, yeah, y is equal to f of x means y1 is equal to f of x1 here. Whatever the limit of f of x as x tends to x1, the this value becomes y1 means it should be equal to the f of x1, that is called function value. It is equal, left continuity is becoming a left continuity means there is a continuity, there is no gap in that, all the closely associated point, you can say that. Therefore the full continuous is there, then we cannot say that it is not isolated point. If there is no left continuity and right continuity, we can directly say that it is point is in discontinuity on both left and right side, you can say that the point is true isolated point. This is how we can understand the point is only true isolated if it is no real neighborhood pattern. One very beautiful example, you can say that y square is equal to x square into bracket of x minus 1. This is very important example. This point is 0 comma 0 is isolated point here, because the neighborhood point of 0, if you take minus 0.001 and whatever this point, in order to get it neighborhood point, what we can first, we have to put x coordinate in the equation, whatever the y is there, whether it is close to the y1 or not, we are going to check it. What we can do, we are coming closer to the first x coordinate, and you have to put the value of y, then whether it is close to the or not, you have to check it here. First, in the similar fashion, I am going to check left side of y, that is minus 0.001. If you choose it, okay, if you choose it, then what happens, this y becomes negative, imaginary, there is no y itself, there is no question of whether it is close or not, means the y is imaginary, means I can say that there is no point associated in the left side or right side. See, up to infinity, open interval of infinity minus big number, the y is becomes 0, minus open interval of minus infinity to the open interval of 1, this y is imaginary, because even though if you take zero point 0.5 also, zero point 0.5 minus this becomes pod negative and y becomes imaginary, means only one point is satisfying this equation. There are no neighborhood points will going to satisfy this equation. What I want to say is that whenever in case of continuous function, what we are doing, suppose we are going to observing the pattern. Why observing the pattern? X as x, we are approaching x value. In order to find out y value, we should put it then that equation. If the whatever the y we can get, it should be closer to the y. Then only we can see. The same thing we are doing here. In order to check it, what we can doing here, we are going to do it whether going to neighborhood point very close to this one and putting the value, and whatever the y value, whether it is close to the y or not, we are going to check it. But what happens, y is getting imaginary here. It means that there's no neighborhood point around that. Means that if it is exist, as we have, if you again, if you bring closer to the x and there is a point associated with, then you can say that there are neighborhood going to satisfy the equation of the curve. But since there are no points exist in around that left side or right side, we can get 0 comma 0, then it is called isolated. If there is no left continuity, there is no right continuity, you can say that it is. And also by observing the pattern, we can say that it is not it is not continuous. It is called, if there is no left continuity and right continuity, you can say that it is an isolated point. This is how we can understand things. Only by half continuous, it may be, if I say the only it is left continuous but there is no right continuous, can I say that tip of the point is called, if suppose you can say that there is a point here, if there is a left continuous is there but there is no right continuous, if it is no right continuous, can I say this is the point as isolated, because there are neighborhood points around that will going to satisfy the equation. Therefore, because that's the reason only, as we left side also you check whether we have to check very close to the x1. Suppose x1 y1 is the point, we have to check the left side point, that is x1 minus delta x. Whatever the y should, you can get y1, whatever the f of x, after putting this value into the f of x value, whatever you can get it, that should be closer to the y1 as delta x tends to 0. Then only you can see, if you, even though if you get a finite number, if you don't get it is closer to the y1, you cannot say that is neighborhood points. Try to understand, it should be closer to, that's the reason only in the continuous function all those things happen. Okay, this is how we can understand.